You're listening to Soundside. I'm Libby Denkman. Learn to code. A decade ago, that slogan was everywhere as computer programming was seen as the job that not only paid well, but also almost guaranteed job security, especially in a tech hub like Seattle. But in the last 4 years, more than 700,000 tech workers have been laid off. And while overhiring during the pandemic and rising interest rates are believed to have sparked most of these layoffs, another issue is looming. It's something that is changing the job of coding itself forever. That's artificial intelligence. Clive Thompson is a tech and science writer who recently spoke with more than 70 software developers for the New York Times Magazine about how AI is reshaping the future of coding. The piece is called Coding After Coders, the End of Computer Programming as We Know It. Clive Thompson, thanks for being here.
That's good to be here.
So there's a lot of talk about AI agents. Can you kind of break this down for somebody who's not tech-minded, maybe has experience with using an LLM, but maybe doesn't know how coders are using AI agents these days?
All right, so basically, if you've used ChatGPT or something, you're accustomed to sort of typing a question or some instructions into a chat box, and then it'll think and it'll give you an answer back. And the way that coders do it is a little bit different. They will sort of install a version of software that lets ChatGPT or Claude or some of the Gemini by Google have control of aspects of their computer. So it can create new folders, and it can change files inside it. If it wants to take some software it's written and put it online for everyone to use, it can actually send it out onto the internet, right? And so the way that they'll work with a large language model is that they will speak to it sort of to a coordinating agent. And they'll say, hey, I want you to write this software. And they'll sort of talk about what that software should do, what its features should be, how it should function. And they'll ask, give me a plan for how you're going to do this. And after they've sort of talked for a little while about what that plan is, and the software engineer is happy with that plan, they'll say, okay, now go and do it. And so that agent will spawn off several sub-agents, like a little team, a little swarm of them. And some of them will start writing the code. And then other ones will take that code and they will test it, which is a way of sort of, subjecting it to a lot of example usages, just to sort of see, does it work the way it's supposed to? And if it doesn't work, it'll sort of emit errors. And then other agents will look at those errors and go, okay, knowing that, let me go back in and try and change the code to fix it, and we'll test it again. We'll sort of keep on going in this loop. And they've got this overseer, like the head agent is sort of, managing all these other sub-agents. And eventually, 10, 15, 20 minutes, however long, when it's confident that it has passed all the tests, it will go to the human and say, okay, it's written. Here, check it out. Here are the tests. I'll show you the tests I did. Here's the results. And so it's a very different way of working with AI. It gives the AI a lot more agency. It can do stuff on its own, and it's quite a bit more hands-off while the work's actually happening. It's very interesting to watch, to sit next to a developer and while they're having these conversations and then seeing these agents go off and report back 15 minutes later.
Yeah, there's so many questions that brings up in my mind, just about the dynamics of that and also the efficiency of a single person being able to spin up basically a whole team of coders on their own using AI agents. But first off, at a most fundamental level, being a computer programmer used to mean learning different languages, like learning to speak computer. But what's happened here, from what I understand from reading your piece, is the computers now speak human, and the coders are just able to talk to them like they would a person, right?
Yeah, exactly. Up until now, the way that if you wanted the computer to add two numbers together, in Python, you'd say, well, the first number, A equals 400, and then you'd say B equals 300, and then like C equals A plus B, and that's sort of adding them all together, right? You're going step by step, and each of these is a little command written in a language that the computer can understand. You couldn't just say to the computer, hey, add 300 and 400 and give me back the result. I couldn't say that in just words. And now you can. Like, you can essentially spec out what the software should do in regular human language and just explain that to the software agents. And they take care of the work of sort of turning that human intent, that human desire, into computer code itself.
But the levels of abstraction, you talk about this, have always kind of gone up and up and up, right? As new coding languages were released. What's the difference here ultimately, like between original like 1979 or 1980s era coding and now?
Well, you're right that coding has always gotten generally easier over the decades, because if you went back 50 years, it was really painstaking. Every single little thing had to be spec'd out. Like every time you wanted to have a number stored, you had to write a command specifically telling it where to put that in the computer memory, and you had to remember where that was, and you had to erase that when it was done. And so that was so hard to do that over time they made languages that kind of took care of a lot of that blocking and tackling for you. It made it a little easier to write. So they've had this 50, 60, 70-year ascent into what they call higher levels of abstraction. It's certainly one of the biggest jumps upwards that I have seen, and I've been sort of writing about software development for 30 years, and I've been programming computers since the 80s myself. So doing it myself, it's very different. It's very strange, I would say. In one sense, it's an evolution in the way the computer code has been written. In another sense, it's kind of a revolution.
I grew up around computer programmers because I grew up in Redmond, Washington, and in the shadow of Microsoft, literally, like right next to Microsoft. And so I've always been around them. I have computer programs in my family, but I've also, as a humanities major, always kind of held them to have this, hallowed knowledge that I could never pierce. Like there was a magic spell that they knew, or literally different languages that they knew that I will never go there. But now it feels like all of that has gone away. Like the spell has broken, and normies like me could ask a bunch of agents to do this stuff. I mean, I guess you interviewed these coders and got a vibe from them about, literally this is called vibe coding, by the way. You got a vibe from them about how they feel about this, the addition of agents and the ease with which they can build things now. I mean, where are their heads at? How are they feeling about all this?
Yeah, it was kind of interesting. When I first chatted with my editors, the New York Times Magazine, back in the summer about this story, some of the editors were kind of wondering. They asked me, they said, is this demoralizing, for software developers? Because like you said, there was this mystique that they had really enjoyed for decades. Not just that this was kind of a mystical, strange, and very difficult practice that they were doing, but it was also worth a lot of money, right? I mean, if you were good at it, you could get really rich. So the editors were kind of wondering, does it feel deflating, for AI to suddenly be able to write code in many cases as well as humans do? It turns out when I started talking to developers, though, that they really weren't demoralized. I mean, they were certainly maybe a little unsettled and freaked out by it, but they were mostly excited because they felt that they could sort of punch above their weight in this remarkable way, because they had this team of deathless robots doing what they wanted. What I realized was that for a long time I had been interviewing developers, and they were telling me the pleasures of writing code, and a lot of it had to do with the fact that it was very frustrating. You wanted to build this thing, but all these bugs and problems along the way, and niggling little things, and finally when you got it working, it felt amazing. I've been going at this for days or weeks or hours or months. Finally, the thing is working, and you felt like a god. And they basically say they still feel that, even though they're not writing the lines of code so much themselves. They still feel that feeling. The feeling has gone from being like a construction worker with the hammer in your hand to being the architect who sort of goes, I have in my mind a building that should exist, and I'm going to spec it out, and then suddenly the building is, much more quickly there. So that feeling of, oh my God, I did it, is still there. It's just sort of moved upwards a little bit. And a lot of the software developers will tell you that they feel that their skills that they learned the hard way of, having to write that code, having to understand how code works and how different chunks of a large software base, the way they have to work together, the way you have to design this thing. They tell me that you still need to be someone who's versed in computer code to be able to get the best out of these agents. If you want to do something complicated, you got to go step by step, chunk by chunk. So you actually have to have a fair degree of expertise. You can't just say to the agents, hey, build me Amazon, build me Netflix. You're not going to get it, right? You definitely.
Yet.
Definitely, you can make some. That's true. Maybe not yet. And the people at Anthropic that make Claude will tell me that they are working very hard at pushing the abilities of these agents further and further and further. They do want it to be closer to make me a Netflix, make me an Amazon, but for now anyway, and we don't know how long. Doing the complicated stuff at a software company, even using agents, still requires you to be very knowledgeable about code itself. And I guess maybe that's what they feel their moat is for now. Although no one really knows how long that moat will last, right?
Yeah, the moat analogy. The moat is there. It's just shallower and maybe a little narrower, right? The gate is a little thinner.
Yeah, and it's also. That moat maybe is unpredictably skinny at times, like definitely, the vibe coding idea that someone who doesn't really understand code at all can now make an app, a thing that does something for them. That's not hypothetical. That's real. I've talked to lots of people. I've seen it. And so you're seeing the emergence of this huge population of people who are kind of, maybe they're code adjacent, right? Like they work in accounting or they work in sales and they have, something they've been doing that's repetitive and boring. My boss dumps 70 PDFs every Friday morning and I have to go through and pull out all the sales figures and put them in a spreadsheet. And that would take them like 3 hours every Friday. Well, now they just dump those PDFs into Claude and say, can you write me an app that every week will take these and give me a spreadsheet with the sales figures, and it'll do it. And then now they just push a button once a week and that's done. And they've made an app by themselves. They don't understand how it works, but it does the job. And I think this is a really fascinating thing that is going to, in many ways, maybe be even more transformative of the world than the fact that software developers themselves are now able to sort of punch above their weight. Everyday people are able to do things that simply were absolutely impossible for them before. And there's a lot more everyday people than there are software developers.
You're listening to Soundside. I'm Libby Dankman, and I'm talking with Clive Thompson. He's a tech and science writer who recently spoke with more than 70 software developers about how AI is reshaping their work and the future. The piece he wrote for the New York Times Magazine is called Coding After Coders, the End of Computer Programming as We Know It. We'll be back with more of that conversation in just a minute, right after this break on KUOW. Welcome back to Soundside. I'm Libby Dankman. Clive Thompson is my guest, a tech and science writer who wrote Coding After Coders, the End of Computer Programming as We Know It, a recent piece in the New York Times Magazine. And so far, we've been talking, Clive, about how coding has evolved over time, how programmers are using AI agents these days. One thing I want to zero in on, though, is there is this weird dynamic that has developed with the way the coders are talking to their agents, and it involves, like, I would call it almost like abuse. I mean, but not because I don't want to anthropomorphize, AI agents, but they're sort of insulting them sometimes when they're talking to them, and they think that actually helps.
Yeah. The language that software developers will use when they are instructing their agents on what to do can be curiously emotional. And I started noticing this because I would hang out and I would shoulder surf next to these people while they were working. And often you discover that they were getting angry or they were yelling, in all caps at the agents. And I would say, so, do you need to do that? Do you need to be so hostile? And they would tell me, well, we've discovered that, sometimes being really harsh actually gets a slightly better effect. We get a slightly better result. The agent is more likely to do exactly what we want. There was one very funny example in the story. So I'm looking at this what's called the prompt file. So basically, if the agents keep on misbehaving in some way, doing something you don't want, eventually you sort of codify this into a central prompt file. It's like the 10 commandments for your agents. Before they do anything, they have to look at these things you've told it always to do. So when you're looking at these lists of these commandments, you're sort of seeing all the pain points, all the ways that they've had to sort of herd these digital cats and get them to behave. This one coder had written a line saying, you have to pass this test. Every line of code has to pass this test. Every function has to pass this test. Failure to do that is unacceptable and embarrassing. And, I said to him, like, is embarrassing? Like, does that actually mean something to these agents? Like, do they, does that work? And he was like, well, I can't prove that had an effect, but it certainly seemed to improve their obedience. They were skipping the tests. They were like not doing the test. And after he said, it's embarrassing if you do that, they started doing the tests all the time. And I was thinking about that. And it kind of makes sense that this very emotional and sometimes very aggressive language would work, because large language models are language machines, right? And so they are understanding words and sentences by the company that those words keep. And so embarrassing is just sort of in a bad neighborhood of language, right? And so probably, to some level, it connotes to the agents that, wow, that this thing that the human told us here, that, yeah, this is serious. It's embarrassing, and embarrassing is a bad word, surrounded by other embarrassing words like humiliating and whatnot. So let's make sure that we really do this thing. And it's very weird. It's because, I've realized as I watch them work that they're not just telling the agents what to do. They're sort of having to cajole them and persuade them and reprimand them, because these are kind of unpredictable things.
Yeah, like the implications of giving an AI agent instructions and then having it disobey them or ignore them and having to literally berate that agent. I mean, the autonomy that these agents have to be able to go off and do the work and build the things and sort of just have one human that kind of looks and checks the work is really useful. But it also seems to lead to this, like, hey, we're doing our own thing, and I'll apologize afterwards if I missed your instructions. I mean, like, of course, we've all had the doomsday conversations a million times, but didn't that terrify you at all, Clive?
No, I mean, definitely, like, there are software developers who will look at this and go, this is absolute madness, right? Like, like these agents, because they behave probabilistically and statistically, they are going to screw things up, and maybe the humans are not going to notice it, or maybe they're going to screw it up in a subtle way. Like, the code will sort of work. It'll pass the tests, but there'll be some subtle problem in the way it's written. It's not very efficient, or it's kind of baggy, or maybe it conflicts with another part of the code base in a way that a human would have understood if they'd done it by themselves, and the agents didn't really understand. And so there are definitely coders who are looking at this and going, this is nuts. Like, I'm never doing this, and no one should do this. And 3 or 4 years from now, we will be in a world of pain, because we might discover that a lot of the code that was sort of excitedly pushed out by these agents and maybe not looked at carefully enough by the humans could be a real flaming mess.
I've talked to coders who say, yes, this is amazing. I really don't write code anymore. I just vibe code. I give it instructions. It's great. But they are worried about their younger counterparts and like people just graduating and what that means for them. Because, once you have the experience to be a senior software engineer and you are able to do that kind of oversight and be the person that provides the checks for the AI agents and for, people who are using them, that's fine for you. What about the latter, Clive? I mean, what is going to happen to the next generation? Are fewer people going to be getting these jobs? Like, are we seeing replacement already happening? What's going on?
Yeah. One of the things that a lot of software developers told me is a version of exactly what you said. They're like, okay, they'll say, like, I'm 40. I've been doing this for 20 years. I have an instinctive sense of whether code is good or bad because I had to write it by hand for 2 decades. I have the mental calluses. I can glance at the output of one of these agents and know, all right, that's good. No, that's flabby. That's bad. Redo it. So I, the mid-career person, am amazingly productive. But how does someone who's 21, how are they going to get to the level I'm at if they're not writing those lines of code themselves? If they go their entire career just sort of asking the agent to do stuff and then looking at it and trying to figure out if this is good or bad, are we going to have a generation of developers 5 years from now that simply don't have the chops? And so that's one worrying thing that no one really had an answer for, right? I mean, even the people who teach computer science are like, well, we're demanding that they learn the basics by hand. If they want to cheat, they can. We can't stop them. And the employment question is really concerning for young developers too. Now, you asked if there was any early softening of the job market, and yeah, there is. There was a study done by Eric Benjolfsson of Stanford And he looked at it and he found that basically software developers in their early stages of their careers, like kind of, age 22 to 26, job postings, job hiring was down by about 16% over the last little while. And that seems entirely attributable to AI. And that seems entirely attributable to AI because he controlled for things like interest rates or whatnot, right? And he did not find that in other industries that are not exposed to AI. Only the ones where AI can really do the job. Have you seen the situation where the people who are in the middle of the career, they're fine. They're getting hired at the same rates because they're very productive. But they're not hiring the young people because what the young people used to do was the scut work. And the scut work's being done in those cases by the AI. No one really knows what this is going to mean for the next few years of hiring. In the short run, it doesn't look like a great trajectory, right? I mean, do I think there will be no jobs for young developers? No. I mean, there's plenty being hired, but it might get harder, and it might mean that you have a little more of a winner-take-all economy where the people at the top of their classes, they'll do okay. But the ones kind of further down, who kind of skated through computer science and they're okay at it, but they're not great, they may find it much harder to get jobs or may not get jobs at all. And this is concerning to some of the professors I spoke to in computer science. They're like, I don't know what to tell my students now, right? It's like, if you're at the top of the class, yeah, you'll be fine. But some of these other ones that used to be able to they were good enough, they were definitely good enough to do the work to get hired. Maybe they don't have a future. It's a tricky one to call.
Yeah, and it feels like such a rug pull compared with just a few years ago when it was that fallback thing. And hey, did your job get disrupted with, an economic downturn in some other way? Just go to coding school. You'll figure it out. It'll be cool.
Right. Yeah. I mean, I 7 or 8 years ago, I was talking to people who did a mid-career transition where they just went to like a boot camp, right? Like a 6-month boot camp, and they would get hired. They would be, maybe not in the big coastal markets, but if you're in, Ohio, in Cleveland, where they don't have a whole lot of developers, and you're 34 years old and you're like, I'm going to retrain as a coder, there would definitely be a bank that would want to hire you, right? And that pathway certainly may become a lot less common and maybe vanish.
The rise of the humanities majors. We get our revenge. No, just kidding. I don't.
Well, actually, I mean, there is a funny thing here, though, because as one of the developers told me when he was thinking about the fact that he was speaking and talking to the AI a lot. That's what the job is now, right? He has to be able to speak and talk clearly and explain very clearly in English what he wants the AI to do. He said to me, I've become a better writer. He goes, it's really weird. Like I'd sort of ignored that as a competency, but I've had to get better at it. Another guy said, I feel like all the nerds are learning empathy now because they have to develop a theory of mind of how this AI works and communicate with it clearly. And I was like, oh my God, these are just classic liberal arts, right? Clear communication, understanding your audience and speaking to it. So ironically,
persuasion, yeah. Uh-huh.
Yeah, persuasion, rhetoric, all these things that, Socrates would have recognized as core attributes of the liberal mind are now becoming part of what's necessary to be a good software developer. I mean, in one sense, a developer would tell me that was always true. Like the absolute superstar developers were actually often fantastic communicators because that was how you got everyone on the team rowing in one direction, and I can attest that's true. Like of the people I've spoken to that are the real standout software developers, they always had they were like Renaissance people. They had everything. They could write these deliciously amazing essays that were very persuasive and get everyone excited about something, and they could also code incredibly well. But I think the need to be a good communicator is filtering downwards to everyone in the field. If they're going to be good at what they do, they need to have some of those liberal arts inside them now.
Before we go, there is this elephant in the room about how few AI companies will be responsible potentially for all the code for every startup, from now on, or for major chunks of, the biggest company's code. And what are the implications of that? Like, Anthropic, Google, maybe Elon, there's like a handful of companies that will then sort of be in some way have a piece of all of this innovation. Like, what does that really mean for us?
Well, I don't think it's good. And quite a few developers, even ones that were excited to use these AI tools, were nervous about the fact that there's a very small number of companies that are making them. And it's not quite a monopoly, but it's close. And they all said, this is not great, right? Up until now, one of the great things about software was that it was very distributed. Like you didn't need much to do it. You just had a free code editor on your crappy laptop, and you could use freely distributed open source code, and you could make amazing things. Like it was very permissionless.
Famously out of your garage. Yes.
Out of your garage. Exactly. Yeah. You're sitting there, you've got your Chromebook, frankly, in a Starbucks, and you could make something amazing. So if you're heading into a world where these very highly capitalized companies that need to make a lot of money are now in control of these central tools, that's not healthy at all. We've seen what that has done to media. We've seen what that's done to social media. So there's a few very far-sighted people that are trying to figure out ways around this. Anil Dash, a friend of mine, he's quoted in my story. He's a longtime developer and a multiple entrepreneur and CEO of tech companies, and he's working on trying to replicate just these amazing advances, but using software models, large language models that you can download and run on your own computer. From, for example, Mistral, which is a model made in France, and it's kind of like the most ethical large language model you can get. It was trained on as much as possible, like data that wasn't stolen wholesale from people. So you can run it locally, and it's not as good as the top of the line models, but as Anil says, it's like 6 months behind, and that's pretty good. So he's sort of exploring and advocating for developers to say, well, try and run this stuff yourself. Like make you the master of the tools instead of handing over all this power to a few small companies. I do think there definitely are ways out of that problem. But it would require people to be very intentional and work harder at building their own tool set instead of just immediately going for the one that's out there in the market. And unfortunately, I think as we've seen with social media, as we've seen with large media, people that come along saying we'll do this for you very easily and frictionlessly, it works, right? And they wind up with an awful lot of power, too much power.
Yeah, and their pound of flesh is extracted. It's your data. It's, the information that you're feeding it. So, yeah, it's not like it's doing it for free. They're doing that for free.
No, exactly. I mean, it becomes one of those things where, well, we have the best tool, and you're going to give us lots of data that makes it better and lets us keep further ahead of everyone else, right? It becomes this winner-take-all economics that, as we've seen, can really deform where power lies in society.
Clive Thompson writes about tech and science for the New York Times, Wired, and Smithsonian. He has also written a book about this subject. It's called Coders, The Making of a New Tribe and the Remaking of the World. His most recent piece for the New York Times Magazine is called Coding After Coders, The End of Computer Programming as We Know It. Clive, this has been a real pleasure talking with you, and really appreciate you going through all this with us.
Not at all. I had a great time talking.
Thanks for listening to Soundside. Don't forget you can listen live on KUOW 94.9 Seattle at noon and 8 p.m. Monday through Thursday, or anytime right here online at KUOW.org, or of course on your favorite podcast app.